Hi, I am Gautam. Welcome to Gchemics. Today I am going to explain about the different solid state systems and their characteristics. So, first, what is a solid? And the answer is that solid is characterized by their high density and low compressibility compared to gas or liquid. In a solid, molecules or ions are relatively close together than the gas or liquids. Classification of solids. There are two types of solids, one crystalline type and another amorphous type. In crystalline solids, a definite arrangement of molecules or ions repeating in space and form long-range ordered arrangement, and so crystalline solids have sharp melting point, flat faces, sharp edges, and also crystalline solids are anisotropic. You can see in the picture. On the other hand, amorphous solids do not have ordered arrangements and it is isotropic, as you can see in the picture again. In this video, today we only discuss about crystalline solids. So first, let's know about faces, edges and interfacial angle of a crystal. So what is face? Crystals are bound by planar surfaces called faces. What is edge? Where two faces meets, an edge is formed. And what is interfacial angle? The angle between the two intersecting faces called interfacial angle. Angle between x and y axis is alpha, y and z axis is beta, and x and z axis is gamma. You can see as in the picture. So alpha, beta, gamma are interfacial angle. Depending upon the various interfacial angles, edges and faces, 7 crystal systems are present. For example, triclinic, monoclinic, orthorhombic, trigonal or rhombohedral, cubic, tetragonal and hexagonal. Each have their own dimensions. Here you should also know that there are 14 Bravais lattice present. This question was 2018 IIT JAM Chemistry, so it is very important. So what is Bravais lattice? Bravais lattice is an infinite array of discrete points in 3D space. All the lattice you know are a type of Bravais lattice. You can see the 14 types of Bravais lattice on your screen, and you should know this. Geometries of different crystal systems. There are 6 geometries, that is simple cubic, body centered cubic, face centered cubic, diamond cubic, graphite layer lattice and close packed, which is 2 types, cubic close packed and hexagonal close packed. In these lattice systems, 8 lattice points present at the 8 corners and total lattice points in the unit cell is 1. Having packing efficiency, that is percent of space occupied by the lattice points in the unit cell is 52% and percent of empty space in the unit cell is 48%, as you can see. Next, body centered cubic, that is BCC. Here, in addition to 8 lattice points at the corners, there is a lattice points at the center also, and total lattice point in the unit cell is 2. So it has packing efficiency 68% and percent of empty space is 32%, as you can see on your screen. Next, face centered cubic, that is FCC. Here, in addition to 8 lattice points at the corners, there are 6 lattice points at the center of 6 faces. Therefore, total 4 lattice points in the unit cell, and percent of space occupied is 74% and percent of empty space is 26% in this crystal. Now, an important point about FCC is that in the FCC lattice, there are 8 effective tetrahedral hole per unit cell, that is 2 tetrahedral hole per 1 lattice point, and the lattice have 4 effective octahedral hole per unit cell, that is 1 octahedral hole per 1 lattice point. Next, DC, that is diamond cubic crystal. This is a covalent crystal and a special type of FCC lattice. Here, 4 additional atoms or ions are present within the FCC lattice. You can see one unit cell of FCC lattice contains 8 small cubes, forming 8 tetrahedral hole. the 4 extra atoms or ions are present alternatively in the 4 tetrahedral holes out of 8 tetrahedral holes. In the DC lattice, total number of atoms or ions in one unit cell is 4 from FCC and 4 from extra, that is total 8, and therefore percent of space occupied, that is packing efficiency, is 34% and vacancy is 66%, as calculation you can see on the screen. Now graphite layer lattice. This is a covalent crystal. The sp2 hybridized carbon atom in each hexagon in one layer are attracted by weak van der Waals force with another layer having distance 340 pm. You should know that the weak van der Waals force is responsible for the lubricant nature of graphite. If you want, I make a special video on graphite layer lattice, then comment below and let me know what do you want to know. Next and the final but important crystal lattice is close packing crystal lattice, which is consist of two crystal forms, one CCP, that is cubic close packing, and HCP, that is hexagonal close packing. So first CCP. The packing of layer ABC, ABC, ABC and continuously it goes on is a CCP or FCC packing, and it's also called FCC, that is face center cubic packing. It has packing efficiency 74% like FCC, and you can see in the picture. And the other is HCP, that is hexagonal close packing. The packing of layer is AB, AB, AB and it goes on is HCP. You can see the picture on your screen. The packing efficiency of HCP is 74% also. So these are the basic crystal lattice in your syllabus. I also give you some example to make you fully understand that. First is NaCl structure. NaCl have FCC structure, 4 atoms or ions, actually ions here, per unit cell. Packing efficiency is 74%, and the CiCl structure, which has BCC structure, 2 ions per unit cell. Packing efficiency 68%, and it has 8:8 coordination number, that is 8 anion coordinated 1 cation and vice versa. And another important part is nearest neighbor. Nearest neighbor means the nearest distance of a lattice point from another lattice point in a crystal lattice. Let's understand taking as an example. Let's take a BCC lattice. Say in the picture lattice point A, the question is what is the distance of nearest neighbor of lattice point A? So A have many neighbor, but we have to calculate the distance of the nearest neighbor. The nearest neighbor is B, not C or C prime or C double prime or C triple prime, because AC or AC prime or AC double prime or AC triple prime distance is greater than 2r. Say r is the radius of each atom, as A and C are not attached in a BCC lattice, but AB, where A and B atoms are attached, the distance is here 2r, which is less than AC or AC prime or AC double prime or AC triple prime. So B is the nearest neighbor of A. So friend, today's discussion is over. If you want, I make special videos on special topics. What you need to know, please comment below and subscribe my channel if you like to get instant notifications when I make a new video for you. So thank you friend. See you again. Jai Hind.